We'll go through a few slides initially to understand what exactly is DevOps and why is it in so much of demand today. Now, we'll get started. Now, before we get started, right, as I said, I'm not really big on slides, so we would not be spending a lot of time on slides. We'll be spending majority of our time on the practicals. But whenever I think the slides are important is when we'll pull them up. And I'm pretty sure you have access to all of these slides in your LMS as well. So if you want, you can obviously go through them in your own time. Now, Andrea says if you can use both Google Cloud and AWS, it would be good. Andrea, if I were to do that, we would need double the time than what we have right now. So I could either use Google Cloud and AWS. Obviously, we can switch between them. You know, we can do Jenkins on Google Cloud, we can do Docker on AWS. It doesn't really matter. So we'll see what it looks like in a while. I just started with Google Cloud because I had the account ready and I had the credits and I'd not really used Google Cloud before, so why not, right? Now, before we get started, right, let's just go through a few questions to see how much do we actually understand. I I think I remember a few people saying they belong to the DevOps team right now. Uh, right, so a couple of guys, 3 or 4 guys, they belong to a DevOps team currently. Now, can anybody answer the question, what exactly do we mean by agile development? It says, why is Agile incomplete without DevOps? So to answer that question, you obviously have to know what is Agile development. So does anybody know what is Agile development? And yes, most of my sessions will be interactive. So I will ask a lot of questions. And again, don't hesitate from answering any questions, even if you think you don't know, because this is your safeguard, right? You can make any number of mistakes here, which you cannot in a company that you're working with. So try to make use of it as much as you can. Now, Karthik says agile is continuous development and delivery. Okay, anybody else wants to give it a try? Uh, Surya says three-tier environment, dev, quality, production. Okay, another answer is agile development uh, is to quickly is to actually reduce the frequency of the deployment is what he meant. Now somebody says CI/CD is agile development. Now Gunjan says doing things quickly. Okay, Sandeep says agile is like build is and fix it or rapid development. Mayur says agile means how rapidly you respond to the changes. Sorry, Sandeep said that. Yeah, I'm sorry, Mayur said that. Yeah, right. Jyoti says continuous delivery, some meaningful product or output. Sanjay says from a developer's point of view, it is very frequent deployment of new features or bug fixes. Heyman says without DevOps, I believe we would be in position to ship. Okay. Mayur says okay. Coding, development, testing, implement, and deploy. Enhancement, delivery. Okay, so quite a variety of answers we have here. So the idea of agile, right? I think we'll talk about it a couple of slides down the line, but let's just see what others have to say. Siddhant says a form of workflow with prime motto of continuous development and deployment. Now, Salvatore says because agile development the focus is on implementation and not on release. Often dev teams are not responsible on maintenance and the DevOps team should be the one to break the wall between the development and admins. Now, Salvatore, that's basically a gist of DevOps. That's not really what Agile would mean. Now, Manjunath says Agile is the follow-up CI/CD with proper planning of Scrum and implementing it as per the client requirements. Okay, so quite a variety of answers. We will obviously go through them. Now, I will be skipping a lot of slides, obviously, because I don't want to spend 2 hours reading the slide because that would put most of us to sleep. So I would skipping the slides that are not really important, and we'll move on to the slides that are important so that on we can spend more time on practicals. Now, Renee, you're actually sending everything in a private message to me. So please don't use the private message. you have another message to like raise your hand and send a message. So use that because everybody's sending me a message there and you're sending me a PM. So I have like three different windows that I have to pay attention to. Okay, cool. So here's a classic example. Now, since most of us have some experience in some sort of IT background, this is something that that you would have always faced. Now, there is a development team and then there's a prod team. Now, prod team would basically mean production team. Some companies like to call it ops teams, some companies like to call it deployment teams and whatnot. But the idea is these are the guys responsible to manage the infrastructure. Now, in this case, the developers they developed something, they wrote a code about an application, and now it's time to actually deploy it. But when the prod team or the ops team tried to deploy the application on the production server, there was something wrong. The application just did not work. So the prod team replied to the dev team that this is the error, this is the problem. This is not really, a server problem. This is not really an infrastructure problem. This is the problem with your application. Please fix it and send me the updated code. At that time, the developers replied with the same application is working on my environment. The same application is working on dev environment, on my laptop, everywhere. But if this application is not working on your production environment, that's not really my problem. I can show you the application working on my environment. Now it's your responsibility to make sure it works in yours. That's the reply by the developer. And the production guy says, I have about 10 applications working in my production environment, and it's only your application that is not working. So in this case, I'm pretty sure it's a problem with development and not the infrastructure. Now, I can't really say, is this guy at the fault here or this guy at the fault here? Because both of them are correct, from their own point of view. This guy is saying if I have 10 things working, and your application is the only application that's not working, then it's obviously not my problem. And the developer is saying that it's working for me everywhere. Now it's your responsibility to make sure it works in your environment. Now, there is always a silo, right? There is always this problem. It's always been there since the early 1990s, since the development phase started. Now, this has always been a problem because the hardcore Linux guys, which I was like 10 years ago, they don't really have any knowledge as to how programming works. They don't really have any knowledge as to how an application works or how do you actually configure an application. What they know is how do you actually set up a server, you manage a server, and you monitor a server. That's the only thing the prod team and the ops team would know. At the same time, the developers would have no idea how a Linux system works. They might be working on, a Mac, they might be working on Windows, and all they are concerned about is if their code is correct. But that doesn't really work anymore because back in the day, you had probably one release or one change every month, every 2 months, every 6 months. But that's not really the case right now. There are like multiple changes being pushed every day. Now, if I had to sit there and manually update the changes on all the server that I have, I would be spending months just for one change, which is not really practical. It doesn't really work that way in today's environment. That's where the ideas of DevOps came into the picture. It's basically someone with enough of understanding of development and profound understanding of how the infrastructure works to be able to break this silo, to be able to read the code and understand what exactly is going wrong and give a uniform platform across all the environments that you have. So the idea is if something is working for my developer, there is no reason for it to not to work in my production environment. If something is working for my QA team, there is no reason for it to not to work in my production environment. So to break the silos, to create a uniform or consistent environment is one of the primary jobs of the DevOps guy. Obviously, there's a lot more to it. It's hardly like 5% of the actual responsibilities that you'd have, but that's the basic idea of this particular slide is to fix the problem of it's working on mine but not working on yours. Cool. Moving on. Now, this is where Agile comes into the picture. So my initial question was, how many of us understand what is Agile? Now, we received variety of answers. Now, I can't really say any of them were wrong. All of them were correct answers. But the definition of agile changes depending on the company or the project you're working with. Agile for you might be something a bit different than agile for somebody else. But the idea is to have as frequent deployment or as frequent integrations as possible. Earlier, whenever somebody used to push a code or when somebody used to merge a code, there were 10 other people that they were dependent on in order to make sure that it's pushed to the next desk. But that's not really the case anymore. You don't really want to wait for five other people to push the code that you have. So agile in a nutshell would mean to have frequently released or frequently packaged application that is not waiting for a chain of command to actually get into the desired environment. That's the very basic and English definition of agile. Now, technically, it would change depending on the project you're working with. But the idea is to not have to wait for people. That's the basic idea. Cool. Now, here's a scenario for DevOps. Now, how many of us understand what is a waterfall development model? Or how many of us understand what is a monolithic application? Anybody? Right. So just in case you didn't understand, I mean monolithic application. So how many of us understand what's a waterfall development model and how many of us understand what's a monolithic application? Hmm. Am I not audible or is just nobody trying to answer? Okay. So, I'm not sure if LMS takes a while to process your replies, but it was pretty quiet for about a minute, and then all of a sudden I received like 10 replies. Okay, so let's just quickly go through them. All right, so waterfall, I'll just read the replies without actually reading the names. Waterfall is something that will be delivered as a single package, okay? One team needs to wait for the other team to finish the tasks, okay? A monolithic application is an application where all the layers, like front end, back end, databases, are on the same server or the same infrastructure, okay? Surya says waterfall model is a specific deadline for tasks allocated, okay? Waterfall model is to go through the phases of traditional development. Now, somebody said it's a single tier application, like feedback will be given, okay, and deliver until the end, okay. Waterfall model is basically the serial manner of the work culture. Pretty cool. Not sure, just heard in the project management. Okay. Waterfall mode is a different phase of software development process, different phases of software development process, okay. Right. So apparently a few more replies that essentially say the same thing. Now, again, most of you are correct in terms of your understanding of waterfall model. Now, when I say waterfall model or a monolithic application, right, think of any banking application. If you ever visited a bank, no banking application is has a microservices these days. Waterfall is where you have a single application. Now, if I can bring up my pen, just a moment. So let's say you have an application that has a front end. Now, front end is basically whatever you're working on. So if a banking application is built on C sharp, then you have a C sharp front end. So that's my front end. It obviously has a back end, which is some sort of data store that is connecting to, and it might have some internal DNS routing. Now, what used to happen back in the day is that all of this was packaged into a single package and was run out of the same infrastructure. So there was always one server that would serve your front end, that would serve your back end, and it would serve your DNS as well. So this is basically what you will call a waterfall model, which is not really used anymore. So if you are familiar with any sort of development, you know for a fact that things are or the services are developed differently by different teams at the same time in all the companies. So that's not really a waterfall model. Waterfall model used to, you can call whatever happened between 1995 to 2008, you can call them what we used to call a waterfall model. But the basic idea is that you have all of your components of the application packaged in a single bundle being deployed at the same time on the same infrastructure. Now, the risk here is that for some reason, now obviously this is a very simplified diagram of a waterfall model, but think about it this way. Take Amazon.in or Amazon.com for an example. Now, if Amazon.com was a monolithic application, or if it was built on a uh, waterfall methodology, it would be a single application. So Amazon.in, here's my website, here's my shopping cart, here's my checkout process, here's my payment gateway. If this was a waterfall modeled application, right? The problem is that if my payment processor was down for some reason, if my payment processor was not working, was not reachable for any reason, this entire application would go down. This entire application would not be reachable to anyone. Now that is increasing the blast radius. The problem statement is that just because one of the areas of the application is down, my entire application is not reachable. So there is a single point of failure, and the blast radius is pretty much the entire surface that you have. Now, that's what used to happen back in the day. What we have now is something called as microservices. Now, what I mean by microservices is that you break or you create small chunks of codes from your existing application and have them run as an independent service. Meaning, think about Amazon.com. So Amazon.com has a shopping cart. It has a user database, obviously, because it's storing all of our details. Then it has email notification. Then it has SMS tracking. Then what else does it? It has payment processor. So now, instead of having to build a monolithic application, they've broken down their application into small chunks of codes that can be deployed anywhere. They don't necessarily have to be on the same server. They can be deployed anywhere and still work exactly, the way Amazon.com works right now. But the benefit here is that even if my payment processor was to go down, my users will still be able to reach to my website. They'll be able to use the shopping cart. They'll be able to, receive the email notification, the text notification. Now all of these would be working, even though my payment processor is not working. So the people that are trying to make the payment, that would obviously not work for them. But the idea is that's hardly like 5% of the visitors that they have. But it's still working for 95% of the customers that are on my website. So the idea is to reduce the blast radius in the event of a failure. So that's what we mean. That's the basic difference between how things used to be developed back in the day and how things are being developed today. So this is what you would call a microservice. Now, obviously, this is not as simple. I'm just simplifying a lot of things for you so that you can understand the terminologies and what are the concepts so that they will make sense to you when we actually move on to the tooling part. Now that's the basic difference. That's the idea where we've come to today. So traditional development was something known as a waterfall model. Now the challenges of the waterfall model was there was a huge waiting time for code deployment. Now because this is a single architecture deployment, whenever somebody or whenever your application development team released a new piece of code or released a new piece of feature, it had to be approved by multiple chain of commands. It had to go through multiple tests that were done manually. It had to be deployed on each and every server manually, which would take huge amount of time. In some cases, it would go up to months to deploy a single line of change in the code. Now that wasn't really feasible from the developer's perspective, right? If you've written a script, or if you've written an application, you really want to see it perform out in the production server, right? But if I were to tell you that it's going to take me 2 months just to get your code up and running, it's really going to be demotivating for you as a developer. So one of the problem is there was a huge waiting time. And because it's not yet deployed, now we are working with two different pieces of code at the same time. So the code that's already on production and the code that you just designed. So you have two different sets of code for the same application that you have to manage. So that's an overhead. That's an overhead for the application team. So there were a lot of problems, when it comes to the waterfall model. And obviously there are resolutions to every problem that you can think of when it comes to DevOps. So what can you do about the waiting time for the code deployment? So there is something called as continuous integration and continuous delivery or continuous deployment to ensure quick deployment, faster testing, and speedy feedback mechanism. Now, this is simplifying it to its core. Now, CI/CD, I'm pretty sure most of us are aware about the term because I saw a lot of people saying CI/CD when I asked a few questions. Now, CI/CD basically takes care of the entire application lifecycle management. We'll obviously see what it looks like and how it's done a couple of sessions down the line. But the idea is whenever the development team makes any changes or pushes any changes to the application, a certain set of tests, a certain set of checks and balances, a certain set of health checks, certain type of packaging, certain type of deployment should be done automatically without having to wait for somebody to click a button or without having to wait for somebody to actually deploy it on a few servers for you. That's the basic idea of application lifecycle management. Now, pressure of working on the old and new code is obviously gone because your changes are deployed almost instantaneously. So you don't really have to wait for anyone to, test the changes that are being made. Now, yeah, I think that is pretty much clear. Cool, right? Okay. Yeah, this is the important part. What DevOps is not. Now, DevOps is becoming really popular day by day, and a lot of people are referring to different jobs as a DevOps engineer for some odd reason. Now, here's a few mythbusters for you. Now, as I said initially, there is no such thing called as a DevOps engineer. It's just a term. It's just a term put together by the HR, by the human resources people, because they can't really put a finger on what exactly is it that we do. Now, if I was to kind of give you a basic idea of what I do when I, work as a consultant with a company, so there are a lot of things that are under my wing there. So to give you an example, right, the very first thing that I can think of is called infrastructure automation. So there are different tools and different, philosophies for this. The second thing that I work on is called application lifecycle management, which is what most of you are referring to when you say CI/CD pipeline. So there is infrastructure automation, there is CI/CD pipeline, there is monitoring, there is log aggregation. So log aggregation, this is one of the biggest challenges today. Now, because people have moved to cloud, think about this. Like if I were to give you a question in an interview, let's say you're working with a company that has about 500 servers in AWS. Now, your job, all 500 servers are releasing some sort of logs every day, right? So they would have Linux logs, the operating system logs, then they would have the DNS logs, or the routing logs, and then they would have the application log. Your challenge is to aggregate all those 500, your challenge is to aggregate the logs from all those 500 servers into a centralized place where you can create visualizations or some sort of visibility about the complete infrastructure you have. Now, this is really difficult than what it sounds like. So this is one of the major challenges in front of companies that have already achieved some sort of automation at this point in time. So infrastructure automation, APM, monitoring, log aggregation, and then comes the feedback loop. Now, if someone was to ask me, what do you mean by DevOps, right? My very simple answer would be to give people capability to serve themselves. That's the very basic idea of DevOps. Is developer having a problem? Yeah, what's his problem? He really has to wait for the ops guys to actually deploy his application. Well, here's CI/CD. You can deploy it yourself. If somebody from finance walked up to me, Nishant, I don't really know how much we spend on AWS every month and what service do we spend the money on. Well, here's the visualizations. You can look at the graph or you can look at the report yourself, you don't really need to consult me anymore. So the idea is to make people serving themselves without having to wait for anyone. That's the very basic idea of DevOps. Now, obviously, all of this is part of DevOps. I'm looking at hundreds of tools here. So it depends on the number of tools that you know, the number of philosophies that you're aware of, what can be implemented in what environment, what can solve what problem. That's all subjective, but the idea is to not have someone walk up to you the next time. That's the very basic gist of DevOps. So DevOps is not about knowing Docker. DevOps is not about knowing Kubernetes. It's not about knowing Jenkins. It's a part of it, all right, but that's not what DevOps means. So if somebody was to tell you that, I'm a DevOps guy, I know what CI/CD looks like, that's just outright wrong. That's not how it works. DevOps is a continuous process of evolving a company from certain state to certain state. Now there might be 100 different challenges in between, there might be 500 different tools in between, but that's not the point. The point is to solve one problem every day. I mean, obviously, I'm simplifying it, to solve one problem every day and help people help themselves. They could be any team. They could be technically, they could be development team, they could be ops team, they could be testing, they could be security or penetration testing, or they could be something as simple as the finance team or accounting team that wants to know the spending. So it's, everything, a little bit of everything is a part of your job. So that's what I would say if someone was to ask me, what do you think is what people mean by DevOps, right? So DevOps is not a role, it's not a person, or it's not an organization for sure. So I can't really point at myself and I can say that I'm a DevOps engineer. Obviously, I say that because that's how people hire you, right? I mean, that's how the human resources people refer to you. But technically, that's not even a title. The right title would be SRE, Site Reliability Engineer. But well, in India, or at least in some cases in Bay Area of New York, probably in some areas of London, people refer to people refer to the automation guys as the DevOps guys. Well, so roll with it. Then DevOps is not a separate team. DevOps is not a product or a tool. As I said, it's just because you know 5 tools, you can't say you achieved nirvana. That's where things get started. That's where things get difficult from. So it's not really a product, or it's not a single tool, or it's not a set of tools. Now DevOps, it's not just about writing scripts or implementing tools. Now, as I said initially, understanding the concepts of why are we using things is really important. Now, when I said I'm going to be using Google Cloud, right, a lot of you said, why not AWS? Now ask yourself these questions. Why AWS? Now trust me, I've worked with all kind of companies, like company as small as 5 developers to company as big as about 5,000 developers in a team. Now, I've worked with a lot of small companies in Bangalore over the past 2 years. Now, the very first thing when I meet them, right, in the very first meeting, the very first requirement they have is we want to move to cloud. That's the only thing they say. We want to move to cloud. And my first question is, why would you want? I mean, obviously, you're saying you want to move to cloud, so you would have done some homework as to how cloud will help, what it will do for you, right? So why do you want to move to cloud? And trust me, they have absolutely no idea why they want to move to cloud. Now, people move to cloud, uh, case in point, if you want to move to AWS, is because AWS offers 100 different services along with the VMs. If you just wanted the servers, you don't really need to be on AWS. But if you wanted identity management, if you wanted a queuing system, if you wanted a Docker registry, if you wanted a private repo, those are the services offered by AWS and other cloud vendors. But if you simply want a server, why AWS? AWS is much, much, much more expensive than any other data centers that you would go with. So it's really important to understand when to choose something and when to not to choose something, because that simple difference may make an impact of about a few $1,000s every month. So again, the really important part is to understand when we move to Jenkins, it's really important to understand when are we going to use Jenkins, why are we going to use Jenkins. Now, as I said, learning the tools is the easiest part. Trust me, it takes you 2 days to learn Jenkins. But the difficult part where people fail is that they don't really understand why they're using it. So when they go for an interview tomorrow and somebody asks them a question that they've never heard of before, they can't really put it in context because they've never really understood why did they use Jenkins to begin with. So right, DevOps is not just about writing the scripts or implementing the tools. It's more about understanding when are you using them. Cool. Yep, I think that's all that we really wanted to do. Now, this is what I mean by agile. So I think this is a really good graph. Now, that's waterfall for you. So it'll take a lot of time to deploy or release a change. In case of agile, the changes or the integration is much more frequent, but that's when comes the DevOps into the picture. In this case, I don't really care how frequent the changes are. They will be implemented as soon as they are made. To put this in perspective, right? I worked with Netflix for I think about 9 months. So Netflix, when I was working with them, Netflix in today's date, they push about 2,000 changes to their production environment. 2,000 changes a day to the production environment, and they have only about a team of 10 DevOps guys working for them. They serve more than a million people, more than a billion hours every, not really a billion hours, I forgot the number, but they have more than a million customers and 10 guys managing the entire infrastructure, and they're pushing 2,000 changes to production every day. The scale is massive, but they've achieved that because they were able to implement the proper philosophies and proper tools at the right time. So that was just an example of what a proper DevOps or what a proper philosophy should look like.